Hello and welcome to this demo. In this demo, we're going to see how to set up a Kubernetes cluster using Kubeadm tool. Kubeadm is used to easily bootstrap a Kubernetes cluster. So this demo is actually divided into two sections. This part, which is the first part, is where we set up the prerequisites. So Kubeadm requires a set of virtual machines to deploy Kubernetes on. So we're going to have to deploy multiple virtual machines where we'll have one master and multiple worker nodes. So we need to set up our lab environment, which is our local lab environment based on VirtualBox and on our laptops. And we need to set it up to satisfy all the prerequisites that are required for Kubeadm. Now, you don't have to follow this procedure of using VirtualBox. You could use any of virtualization technology as you prefer. You don't even have to have it on your laptop. You could have it in a lab environment or on a cloud environment. It doesn't really matter. All you need is 3 VMs, each with unique host names and unique IP addresses, static IP addresses. And we are using Ubuntu virtual machine, so you could have Ubuntu or any other supported virtual machines for Kubernetes. So if you have your own ideas of setting up lab, go ahead. You can skip this lecture and go ahead right now and meet me in the next demo and work with me to set up Kubernetes using Kubeadm tool. Okay, so we'll go back to the Kubernetes documentation page at kubernetes.io and click on documentation. We'll go to setup, and under setup, we'll actually go to the left-hand side section where we have setup and expand the independent solutions. And as you can see, the first option there is via Minikube, which is what we already saw. And the second option is bootstrapping cluster with Kubeadm tool. And so we're going to click on that, and that is where we have all our instructions. So when you click on that, you see the installing Kubeadm section, and this is where we will begin. The first section, as you see, says before you begin, and these are some of the prerequisites, and this is what we're going to work on in this video. Firstly, one or more machines running on any of these operating system flavors. So what we have is the first one, which is Ubuntu 16.04. So we already have the images for that, so we can use that to create multiple virtual machines. Each virtual machine must have 2 GB or more of RAM, 2 CPUs, full network connectivity between the machines in the cluster. It must have unique host names, MAC addresses, and product UUIDs. And we're going to make sure we do, we meet all of these requirements. We are also going to make sure we have a unique static IP address assigned for all of the virtual machines. And certain ports must be open and swap disabled. So that is the last prerequisite. Okay, so we're going to, as the first step, we're going to deploy multiple virtual machines for our use. So for the sake of understanding, I've put together this slide with the various steps involved in setting up Kubernetes using the Kubeadm tool. So as you can see, there are 6 steps. The first is to deploy and identify a few virtual machines. So we're going to have one master and we're going to have 2 worker nodes. So that's the first step. And then the next step is to install Docker on them. The third is to install the Kubeadm tools on them. And then we initialize the master, create a pod network, and join the worker nodes to the master. So this is the high-level steps that we'll be following to set up this lab environment. So here we are at the first step where we're deploying virtual machines. In my Oracle VirtualBox Manager, I'm going to click on New to create a new virtual machine. I'm going to name it as Kube-Master, and that's going to be my first virtual machine. As we saw in the prerequisite, the amount of memory should be 2 GB or more. So I'm going to set the memory to 2 GB and click on Next. And I'm going to use an existing virtual hard disk file. This is what we already have, what we used in our previous lab environment. So I'm going to use the Ubuntu 16.04 64-bit image, which is the .wdi file. So I now have my master VM created, and before I power it on, I'm going to go into the settings and make a few changes. So if you go into the system section, you can go into the processor, and as you can see, you need to have 2 CPUs. That was one of the prerequisites. So I'm going to move the CPU to 2 CPU. I already have memory assigned as required, and I'm going to go into the network section. I'm going to set up a bridged adapter. So the default option is NAT. I'm going to change that to set it to bridged, and it's actually going to bridge to my wireless adapter, which connects to my Wi-Fi router, and that way I can access the internet. So all of my virtual machines must have internet connectivity so that I can install the prerequisites, etc. So I'm done with the settings. I'm now going to take a snapshot. This is a good practice. So before powering it on initially, I'm just going to take an initial snapshot so that in case something goes wrong, I can come back to my original state. And then I'm just going to right click and start my virtual machine. My virtual machine is now powered up. I'm going to log in using the default user password, which is osboxes.org. Once it's powered up, I'm going to open a terminal window. So I'm going to search terminal and open a terminal window. And I'm going to run the ifconfig command to see the IP address assigned to it. As you can see, it's got an IP address 192.168.1.86 assigned to it, which is good. And that's the IP address assigned through my bridged adapter. I'm now going to see if the SSH service is running, because by default, these Ubuntu systems do not have SSH service running. And as a result, you will not be able to SSH into that. So we need to be able to SSH into that VM. So I'm going to have to install SSH service. I've already explained this in one of the previous demos, so I'm going to skip that for now. And I'm just going to install SSH myself. And so now I have installed SSH, and I'm going to run the service SSH status command, and as you can see, the SSH service is active and is running. I should now be able to SSH into this VM. I'm going to use the IP address to SSH into it using my SSH terminal application. I'm going to use username osboxes. And I'm now at a login prompt. I'm going to input the password, which is osboxes.org. Okay, once I confirm that I'm able to SSH into it, I'm now going to shut it down. So I'm going to run the shutdown now command to shut down my server. The reason is I would like to use this as a template to clone other virtual machines. We only have one master deployed for now. I'd like to deploy 2 other worker nodes. So I'm going to right click and click on clone. I'm going to name the new machine that will be cloned out of the master as node 1. So I'm going to name it cube-node 1. And remember to check the reinitialize the MAC address of all network cards option. This is required because each virtual machine must have a unique MAC address, and that is a prerequisite. And so checking this will help us with that. And the clone type, there are 2 options available, full clone and linked clone. If you have not worked with this before, the difference between the 2 is that a full clone creates a full copy of your virtual hard disk, that way consuming a lot more space on your hard disk, whereas a linked clone it does not really create a full copy of the virtual hard disk file. So that way it only consumes a minimal amount of disk space. So I'll go with a linked clone. That's going to be sufficient for our use case. And so there it has created a clone. I'm going to create another clone for my second node, and I'm going to name it cube-node 2, and make sure to check the reinitialize MAC address option, and I'm going to select a linked clone option as well for this. So now I have all the 3 virtual machines. I'm going to power up all of them right now. Okay, so my master as well as the nodes are all powered on and I'm logged into it. I'm now logged into my master, and when I run the ifconfig command, I can see that it has the same IP address as before. If I look at the other virtual machines, they also have an IP assigned to them. My node 1 is 192.168.1.92, and I'm going to try and SSH into it just to make sure I'm able to do that. Okay, so I confirmed that I'm able to SSH into all of my nodes, which is good. The next step is to set host names, unique host names for these. As you can see, all of them have the same host name, which is OS boxes, which is the default host name. So I need to set the right host name for each of them. What I'm going to do is first I need to be the root user. You need to do 2 steps to set the host name for each node. So you need to go into the file /etc/hostname and update the hostname in the file. Only then the hostname is going to be persistent across reboots. So I'm going to use the VI editor and go into etc hostname, and I'm going to delete the existing name and I'm going to name my master as kubemaster. I will now save that. The second step is to go into the etc hosts file and update the host name here. As you can see, you still have a OS boxes name there, so you're going to rename that to kubemaster. And then I'm going to shut down my system. Okay, and I'm going to do the same with the other nodes. I'm going to edit the etc hostname file and name my worker node, the first worker node, to kube node 1. And then I'm going to rename the host name in the etc hosts file. I'm going to remove that and name it as kube node 1. And I'm going to shut down that host. And I'm now going to go to the third node, which is node 2. And I'm going to repeat the steps to update the host name on this node. Okay, so I have updated the host name on all the nodes, and they're all powered off. Now, I actually powered them off instead of rebooting them because there's something that I want to do next. Now, so far, these hosts or these virtual machines have an IP address assigned to them, which are actually from the bridged adapter on my Wi-Fi router network. So the IP addresses that these virtual machines are getting, which is in the 192.168 range, is actually the IP assigned by my Wi-Fi router at my home. Now, these IP addresses are provided by the DHCP service on my Wi-Fi router, so they can change. They're dynamic and they're not guaranteed to be the same IP addresses every time. So sometimes when you reboot these hosts, when they come back up, they may have a different IP address than the one that they had before. So this is not going to work well with Kubernetes because the communication between the master and the workers are through the network, internal network, and they rely on these IP addresses to communicate with each other. So these hosts must have a static IP address assigned to them. Now, I cannot achieve this with my bridged network, so I do not have an option to assign a static IP address on that network or on my Wi-Fi router. I do not want to mess with my Wi-Fi router. So an alternate way is to create a new network, which is a host-only network that will be used as the Kubernetes network for the interaction or communication between these nodes. And so when I create a new host-only network, I can actually disable DHCP on that network. It will be a network created inside my laptop, and my laptop will have an interface, a virtual interface on that network, and all of these virtual machines will have a virtual interface on that network, and I can assign static IP addresses for these VMs on that network. So in order to do that, you need to go into Global Tools, click on Global Tools in the top right corner of the Oracle VirtualBox Manager interface, and there you'll see a list of networks, host-only networks that are already created. sometimes you may have one that is created by default. If that is the case, you can actually use that, or if it's not there, you can click on the create button to create a new virtual host only Ethernet network. In this case, I'm just going to go ahead and use the same one, which is in the range 192.168.56.1. And you can see the DHCP server option is unchecked. So make sure that you uncheck this. And if you look at the network configurations for this, the IP address, you can see the IP address for this network on my laptop, which is 192.168.56.1. And so that's the range that I should be using. Okay, so now that I have identified the host-only network, the next step is to attach these virtual machines to that particular network. So in order to do that, right-click on each of these virtual machines, click on Settings, and go into the Network section. We know that the adapter 1 already connects to the bridged network, which is good, and we actually need that for enabling internet connectivity for these VMs, because we're going to connect to the internet to download and install packages. And what we could do is utilize the second adapter, which is adapter 2, and enable that particular adapter and set the attached to option to host only adapter, and select the network, which is VirtualBox host only Ethernet adapter, and that's what we're going to connect to. I will leave everything else as default, so I will leave it all to the default option. So I now have two adapters on my virtual machine, one to the bridged one bridged to my router, and the other, which is a host only network adapter. I'm going to click on OK to confirm my changes. I'm going to duplicate the same changes on both the other virtual machines. Okay, so I've made the changes on all the three VMs, and now I'm going to power them up. Okay, so all my virtual machines are now powered up. I'm going to open up a terminal on my master, and now when I run the ifconfig command, I can now see that there's a new interface, which is actually called ENP0S8, and that's the new interface that was created, which is attached to the host-only network. As you can see, it doesn't have any IP address assigned to it. So what we're going to do is, there are two ways to assign an IP address. One is I could simply use the ifconfig command, specify the interface, which is ENP0S8, and assign an IP using this command. So just set the IP address. I'm not the root user, so I'm just going to switch to the root user, and I'm going to attempt to run that command again. So that's ifconfig enp0s8 192.168.56.2. So this actually does the trick. It assigns the IP address to my interface, and I will be able to access this virtual machine using this IP address. However, this is only temporary. As soon as you reboot your virtual machine, this IP is lost. So this is a temporary way of assigning an IP to the virtual machine. So this is not what we want. We need another way to assign a permanent way to assign an IP address to the virtual machine. So in order to do that, we need to go into the etc network interfaces file. So we need to edit this file and add the IP address to be assigned to this network into this file. So as you can see, this file already has an entry for the LO interface, which is the loopback interface. We're going to add a new line, a set of new lines to configure the new interface for the host-only network. And so we're going to the first line of entry is going to be auto enp0s8. And what this does is it automatically enables or turns on this particular interface when the operating system boots up. So we want it to automatically come up every time we boot up. The next line says iphase enp0s8. inet static, so that indicates that the this particular interface has a static IP address, and then in the next line I'm going to specify that address, which is 192.168.56.2, and on the next line I'm going to specify the net mask, which is 255.255.255.0. And that's it. That's all I need to do. I'm going to now save this file, and I'm just going to reboot. This way, when it comes back up, it should automatically have had that IP address set, that network interface enabled, and IP address set. I'm going to duplicate what I did on my other virtual machine. So I'm going to go into Cube Node 1. I will edit the network interfaces file, and I'm going to use the same set of lines I used on the previous one, except for the IP address, of course, which is now going to be set to 192.168.56.3. And the net mask is going to remain the same. And I will save that file and reboot the host. And I will do the same with my second worker, which is Cube Node 2. I will modify the etc network interfaces file and add a new entry with a new address, which is going to be 192.168.56.4, and I'm going to reboot that system. Okay, and now I'll wait for all the systems to come back online. They're now back up, and I'm going to go into the terminal for my master. And there's one more thing that we need to verify to make sure that everything is set up properly. You need to make sure that you have internet connectivity. So what I'm going to do is I'm going to open up a terminal, and I'm going to ping an external website like google.com, and I need to make sure that I receive a response. Okay, so the last thing that I need to do is disable swap. So as it says, you must disable swap in order for kubelet to work properly. And that's what I'm going to do next. So I'm going to go on each of my system, and I need to do two things to make switch off or disable swap. The first is run a command swap off -a, and then the next step is to go into the etc fstab file and comment the line out for swap, which is the bottom line on this file. So I'm going to add a hash in front of that line to comment it out. This way, when I restart or reboot my virtual machine, it doesn't automatically enable swap. Okay, so that's it. We're done with all of our prerequisites that are necessary to install and get started with the Kubeadm tool. We're now ready to use the Kubeadm tool to initialize a Kubernetes cluster. Well, thank you very much for your time, and I will see you in the next demo.